Before the slide start, I can introduce myself. I'm Matej, I'm Android developer working at Microblink, and welcome to the only Kotlin talk this year. We will be talking about Kotlin Java Interop. So before we get going, I'd like to know how many of you use Kotlin more than you use Java nowadays. Anyone? Okay, just one guy. Nice. Then it doesn't count. Okay. Then we'll spend a bit more time on differences between Kotlin and Java, and I'll try to convince you to start using Kotlin. I guess we can continue. So the first slide would be just one sentence, and doesn't it just work? So you've all heard how Kotlin brags about Java interoperability and that you can just start using Java libraries in Kotlin and call Kotlin from Java, and most of the time it just works nicely, but especially when using Kotlin code in Java, you'll need to make some changes to make the Java code look nicer. So I'll show you one example of how ugly Java code that calls Kotlin can look like. So the Kotlin code has this calculator class, and there's nothing weird there. But when calling it from Java, first we have this weird calculator kt. Then in second line we have this weird get has even value. Then we have this dollar module. Another weird thing is this dot companion. And lastly, we have this get default multiplier. So why is this Java code so ugly? Well, it's not the same language. So Kotlin and Java are different languages after all, and some of the differences that cause these problems are, for example, null safety. So as you know or don't know, in Kotlin you have to, for each type, say is it nullable or not. So it's part of the language, whereas in Java anything goes and anything is nullable. Then you have extension functions, which basically means that you can extend the existing classes with new functions without actually extending them. And related to that, you also have top level functions and other code which in Java doesn't exist. There you need to have all code in classes. Then we have properties, where in Java we just encapsulate our fields with getters and setters. Another difference is that Kotlin has companion objects and objects in general, which are basically language level singletons that in case of companion objects are tied to a class and can be used similar to Java static methods. What Kotlin doesn't have is checked exceptions. So in Kotlin you just don't have those. Same is with primitive types, but when Kotlin compiles to Java bytecode, it will use primitives where it can. And as I mentioned previously, there are no static methods in Kotlin. Another difference is with visibility modifiers. So in Kotlin, there isn't package private visibility, but instead we have internal visibility, which basically means that that code can be accessed only in the same module. Now, what does module mean? It depends on your build system ID. It's basically a project, and it works as expected. For example, in libraries, if you set something to internal, you'll be able to use it in the same library, but you won't be able to use it in client code. Okay, so back to the example. This is Kotlin code that caused that ugly Java code, and as you can see there, it's a bit forced example just to put a couple of Kotlin specific things in it, and I've tried to write it in a way that will make the Java code as ugly as possible. So first at the top, this triple is on int extension function. Next we have a calculator class that has a property, has even value, and then we have one internal calculate method, and here we have another Kotlin specific thing, which is default parameter value for the offset parameter, which is set to 0. Then we have a companion object which has a default multiplier property and random multiplier function. So what we'll do next is basically go line by line and fix the mess from the slide at the beginning. So let's start with this top level function. As you can see, it's called similar to Java static methods, but there's this weird KT in the name. So what happened there is basically by default Kotlin will take top level functions and compile them into new file, and it will just append KT to the Kotlin file. If we want to fix that, we add a add file JVM name annotation, and we just say the name that we want to override the generated file to. So if we say int utils, we'll be able to call the triple method by saying int utils.triple. And there's this other annotation, add file JVM multi-file class, which allows you to have multiple methods across different files and compile them into a single class called, in this case, int utils. Then renaming getters. So what happens with Kotlin properties that aren't supported in Java? Well, they'll be turned into fields with getters and setters, depending on whether the setter is available. So by default, it will just append getter set to the property name. It only handles special case for property starting with is, but in this case it starts with has, so it looks ugly like this. But we can fix that by using another annotation at get JVM name and just say to which name we're changing it to. So here we say we want to change it to has even value, and now we're able to use it like this, just dot has even value. Then we have this weird dollar module syntax. What happened there is that we had an internal method, and basically since in Java internal visibility doesn't exist, the best Kotlin can do is make the method public, but somehow discourage you from using it from Java. So it just appends this dollar module, and this also means that it will look ugly like this, not just in other modules, but also if you have a mixed code base in Java, you'll have to call this method like this. We can override that by, well, not using internal, or alternatively with JVM name, and here we're setting the method name that we'd like to change it to. So if we say JVM name calculate, now we can call that method by just saying calculator.calculate. In Kotlin, we also have default parameter values. So for calculate method, you might have seen that the default value is 0. So in Java we're still passing in that 0 because Java doesn't support default parameter values, but there's another annotation to take care of that. So you can just say JVM overloads, and what will happen here is basically the compiled Java bytecode will have extra methods that take care of passing in default parameter. So so our new Java code will be able to just leave off the 0 at the end. And since Java doesn't have static methods, we usually just use companion objects to achieve something similar, but when calling it from Java, you have this weird syntax where you have to say calculator.companion, but you can take care of that by just add the JVM static annotation. And after doing that, you can just call it as expected without the companion part. And next there's this weird get default multiplier. So what happened there is that even though we're using this as a constant, the Kotlin compiler turned it into a field with a getter. So if we want to avoid that and expose it as field, we just add JVM field annotation. And after doing that, we can just say calculator.default multiplier. So here is the final Java code after all those changes. As you can see now, it's not as ugly as before. And here is the final Kotlin code, and unfortunately, yeah, Kotlin code is now a bit uglier. So you might be saying that's a lot of annotations. Do I really need all that? Well, as I said previously, this example is kind of forced just to put in as much annotations as possible. In your regular code, you probably won't need to do all that. And there's also second part. So if you're writing mostly Java code but want it to be usable from Kotlin, what can you do to make it nicer? Most importantly, you can add a nullability annotation. So as I mentioned previously, in Kotlin you define each type as nullable or not nullable, and that way you know for sure that some values will never be null, and you don't need to have null checks for them. But when using code from Java, a third type is introduced. So that one is called platform nullability, and it basically means that it can be null, but is not guaranteed to not be null. And Kotlin simplifies it a bit by not forcing you to do null checks on that type. So it's basically, you call it from Kotlin just like you would from Java and never know what's null. But if you add not null or nullable annotations to your public interface, that code will be able to be used as Kotlin nullable or not null type. Then there are a couple of Kotlin keywords that are different from Java. So what can happen is, if for example you have a method named when, if you use that method from Kotlin, you'll need to put it in these strange backtick symbols. So I don't even know where on keyboard that is. So please just don't use names like those. And then since Kotlin has properties and Java doesn't, Kotlin will try to allow us to use property syntax wherever possible. But to do that, your code needs to have a standard get set method names, or also is prefix is supported. But as you've seen previously, if you have a getter that starts with has or something similar, it won't work, and Kotlin clients won't be able to use property syntax. And lastly, probably something you're already doing, but if you have parameters that are eligible for same conversion, just put them in the last place, which will allow Kotlin clients to use trailing lambda syntax, which basically just means that you can put lambda outside of parentheses for a bit nicer code. So, in conclusion, as I've shown you, it doesn't just work. You need to do some work to make it easier to be used from other language, and this is important if you have a mixed code base, or maybe you're developing a library. And yeah, so the changes are mostly adding some annotation. So the only troubling part might be marking all your Java code with nullable or non-null, but yeah, that's all you need to do. So thank you, and feel free to ask questions.